Okay, so this is a calculation, and the question is given as an equation, but it wants us to calculate the atom economy for the production of sulfur dioxide. So that means the sulfur dioxide is what we call the desired product. That's what we want to make. Okay, so the way we get into this question is we use the equation I've got written here, which says that the mass of the desired product divided by the total mass of all the products multiplied by 100 gives me the percentage. Okay, so let's drop some numbers into this. So the desired product, it tells me sulfur dioxide, the relative formula mass is 64. So I've got 64, and I'm going to divide that by the total mass of all the products. So that's sulfur dioxide plus iron. Now, iron, yeah, just iron on its own. Now be careful because iron tells you here that it's 63.5, but there are 2 moles of that in there, so that becomes 127. So that's the only time we use the moles in a calculation in this way. Okay, and then we multiply that whole thing by 100. So if I do it on my calculator, I've got 64 divided by, and then I've got 64 plus 127. That equals that, times it by 100. I'm getting an answer here of 33.5. Now I've got to be careful because it says give your answer to 2 significant figures. So that's going to become 34 and a percent. So in terms of marks in this question, they're definitely going to give you a mark for doing that bit. They're giving you a mark for remembering to multiply by 100. They're giving you a mark for working out the total mass, and a mark for writing that equation down in the right way as well. So there's lots of marks being thrown at you for doing that calculation. Okay, based on the position, which one shows the most likely melting and boiling point of this? So this here is a transition metal. It's in the middle part of the periodic table. So once we know it's in the middle part of the periodic table, we should remember our core knowledge. Transition metals have very high melting points. So that means it can't be that one and it can't be that one. And they always form coloured compounds. So that is white, and that, so it could be that, but it's got to be that one because that's too low and that's too low. So the sensible option is option D because it has a high melting point and it forms a coloured compound. Carrying on, we've got a calculation to do here. It says calculate the maximum mass of sulfuric acid that could be produced from 400 tons of the sulfur trioxide. Right, so want to find the mass of this, and we're told we have got 400 tons of this. Let's put the numbers in. Over here, I'm going to write down that Mr. Moles lives underneath the mass. Okay, to get into this question. And my first job I'm going to do is convert and get the moles of SO3. So according to a triangle, moles of SO3 is mass divided by the MR. So the mass is 400 divided by the MR is 80. So here I've got 400 divided by 80, and that is giving me an answer of 5. Now, I've got to be careful because I can see here that my ratio is 1 to 1. So therefore, if I want to work out the mass of sulfuric acid, H2SO4, according to a triangle, the mass is MR times moles. The MR this time is 98. Times it by 5, so 98 times by 5, and I'm getting an answer here of 490. Okay. Using a different amount, it was calculated 700 tons of acid could be made. The actual was this, calculate percentage yield. So percentage yield, we have a formula or an equation to work this out. Percentage yield is the mass that you got divided by the total mass you could have got, and then you multiply it by 100. So in this question, they produced 672, but they could have got 700. times that by 100, so it's 672 divided by 700, and then times the whole thing by 100, and that is equal to 96, and that's 96%. Okay. Two reasons why it's less. So there are three reasons why it's less, and it's worth just going through all three. So we're going to add three here just to remind you. So the first one is that the reaction is incomplete. So we have an incomplete reaction would be the first reason it would be less. Second reason is loss of chemicals. So you could have reactants or products escaping. And the third reason is you get unwanted side reactions. You only need two, but I'm just reminding you that there are three reasons